This example focuses on graphing the very basic trigonometric functions without the use of a graphing calculator. We're actually not going to plot points here. I am going to use a different approach that splits up the basic sine function into 4 steps and just graphs by steps without having to plug in the points every single time. All right. So the question itself says graph 2 full periods of this function and state the amplitude, period, and midline, and then label the x-intercepts and the max-min values on the x and the y-axis. Now, we're going to go ahead and start by labeling the amplitude, period, and the midline. So the amplitude, we do have a different value for. The amplitude here is the absolute value of 6, so 6. Now the period, since we do not have any numbers in front of the x, the period is just the fundamental period for the sine function, which is 2 pi. Midline, we do not have a midline. This function is not shifted up or down, so midline is at 0 or the x-axis. You can also say y equals 0. All right. Then the second step that you should do is decide whether or not the grid that's provided will work for you. Now, my period is 2 pi, and every single sine function, the graph of it is the period divided into 4 equal steps. So my step size here will be 2 pi over 4, which is pi over 2. My x-axis is already labeled in pi's, and it is very nice grid. It will work for me just fine. Now, my y-axis, not so much though, because my y-axis only goes to 3 and my amplitude is 6, which means I actually have to go to 6 instead of 3 or 1 or whatever that number is on the front of the function. Since this is not going to work, I am going to relabel it. So instead of 1, I'm going to say 2 here, I'm going to say 4 here, and I'm going to say 6 here. And the same with the negatives. -2, -4, -6. The numbers are fairly small on the grid, so you can definitely change them. Now let's figure out how to actually graph this function. This graphing technique relies on you knowing the parent shape of the function y equals sine x. So you should know that every sine goes through 0, 0, unless it has been shifted up or down. So at this point, this is your starting point. Your step size is pi over 2. So pi over 2 for us, I did not label this, but it is 2 squares on the grid. Since this is pi, this will be pi over 2. So pi over 2, my sine goes from the 0, 0 into a maximum. So it's going to go up to 6 because that's what my amplitude is. Then the next step, so 2 more squares to the right, the next step will be the x-intercept at pi. Then the next step will go into a minimum, and the minimum is at -6 because my amplitude is 6. Now, another x-intercept, and that is 1 full period, but we need 2 of them. So keep going. 2 squares to the right is another max, 2 squares to the right is another x-intercept, 2 squares to the right is another min, and 2 squares to the right is another x-intercept. So the pattern is start at 0, 0, max, x-intercept, min, x-intercept, max, x-intercept, min, x-intercept. Connect the dots with the smooth curve. All right, that is the graph of 6 times sine x. Now let's try this with cosine. So with cosine, this amplitude is the absolute value of 1/2, so it's 1/2. my period is still 2 pi. This function is not shifted in any way, shape, or form. There's no number in front of x, so it's not stretched or compressed. There's no midline. So it would be y equals 0 or x-axis. Let's talk a little more about this period. So just like my sine function, this will be split into 4 equal steps, which again gives you the step size of pi over 2. And that is 2 squares on our grid. Once again, the x-axis is labeled with a nice grid. It is in pi's, it's in radians, and it will work just fine for this question. But the y, you could use it, but it's not ideal. Let me go ahead and change the y a little bit. So instead of this being 1, I'm actually going to make this 1, which will make this 1 half. And then this will be 1.5. And then in the negative direction, this is going to be negative 0.5. This will be negative 1, and this will be negative 1.5. That just gives me a little bit extra room to work with. All right, cosine function. Cosine does not start at 0, 0. It starts at its maximum value. Well, the maximum value here is 1/2, since that is what our amplitude is. So we'll go ahead and start at 1/2. And then after the max, it is going to go step to the right into the x-intercept, then step to the right into the min, step to the right into the x-intercept, and so forth. So my step size is 2 squares or pi over 2. So that is this right here. Then min, then back into the x-intercept, back to the max, back to the x-intercept, back to the min. We have to have 2 full periods, so we have to keep going. All right, connect the dots. You do need to know the shape of the function for this. But if you know the basic shape of cosine, then stretching or compressing it, changing the amplitude is fairly simple. All right, let's go ahead and talk about the labels. It says label the x-intercepts. So this part right here, this is pi over 2. You could label all of the x-intercepts. Really, just the first one is fine with me. And then the max and the min values. It looks like for the cosine, they are already labeled because we labeled the y-axis, and the maxes and mins happen to be on the values that are already labeled. So this is already labeled, this is already labeled, so we're good on that one. Let's check our sine graph. I did not label everything in there. So we have the first maximum is labeled. My x-intercepts are already labeled. This was pi. It's kind of, my line is going through it. 2 pi is labeled. Let's go ahead and label a min. So this one right here. And that would be 3 pi over 2. If you don't know how to think about it, that is pi. So this number right here, plus a step size, which is pi over 2. And pi plus pi over 2 is 3 pi over 2. You don't need to clutter the graph and label the other maxes and mins. This is perfectly fine. Just label the first one that you got on your graph.